We're going to quick go over the exam. So you've already read the questions. I'm not going to re-go over them. I am just going to present them and talk about some common errors that I saw. So the grade you get on blah, 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 depends on the number of hours you study each night. So depends on the number of hours you study each night means you study some more, it goes up. If you study too long, however, you might score because you're too asleep, blah, 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 blah. And so it has to go down at some point. Now, it has to all be in the positive x values, because if you're in the negative x values, somehow time is negative, and that cannot happen. And what type of graph has it? This is a quadratic. Would have also accepted parabola, anything like that. Sure thing, upload. Next. So 3. With 3, this is x to the third power. Because it's x to the third power, this has to be a cubic. You could have also put in polynomial. You could have also put in a power function. A lot of folks got this one weirded out. That's an exponent of 3. This is 5 times 3 to the power of x. It's not linear. So this answer is exponential. 5. So you have the domain, you have the range. Cool, cool, cool. Which means, you need the range. Range is going to be this way, the highest values of my y. So it has to be all these y values. And this is at about 1, 2, 3, 4. I accepted 4, 4.1, 4.2, anything like that. This is at about 4.9, but the 4.9 is negative. So your answer has to be something like this. Negative 4.9 is less than y is less than 4. Has to be y, has to be less than, because or else you can't have a positive less than a negative. It does not work. So this one, what type of function is a graph like this? This is a rational function. It would help if I could spell. Reason it is an inverse variation is inverse variation will hug the axes like this. Rational functions like this one can have what we call a slant asymptote, like that. Inverse functions cannot have a slant asymptote. Silly me. Exponential. Transformations. So we're going from the dashed to the solid. That's pretty important. I accepted a lot of different ways of describing it. However, with all of these, you couldn't just put transformation, dilation. You had to be specific. For this first one, it's moving from here, 1, 2, 3, 4, 5, 6, 7, 8. So you could have put a translation of 8 to the left. You could have put g of x equals f of x minus 8. X plus 8, because it's in the parentheses, so therefore it is different. Let's take a look at this one. This one is clearly a dilation. We're going from f and going up to g. I know it's a dilation, not a translation, because it still has the same roots. Those have not moved. It's going by a scale factor of 3, like that. 4, because I'm going from this value of 1, 4 to this value of 1, 1, negatives. So that means it has to be a scale factor of 1/4. Now, this is a vertical, so it has to go on the outside and remains unchanged, like that. You don't need the second set of parentheses, but oh well. We want to identify this transformation. Now, it clearly got wider, so it's not a translation, but this stayed the same. So this is another dilation. because the root stayed the same there, we can go off of that. So this went from the point 2 comma negative 3. That's a really terrible way to do it. Let's do it up here. So this went from 3 to 6. Because it went from 3 to 6, this is a dilation of 2. It's a horizontal dilation, so it's going to happen inside our parentheses. But remember, what happens inside the parentheses here has to be the opposite. So instead of multiplying by 2, I'm multiplying by a half. You could have also put, instead of that, x divided by 2, because that's the opposite of multiplying by it. Either one was acceptable. You could have also described that it was a vertical dilation, scale factor of 2. That would have been fine as well. This one, we have a translation. None of the roots are the same, so that tells me it's not a dilation. The general shape stayed the same, so it's not a dilation. So it's a translation. It just shifted 2 down, so I can say g of x is equal to f of x minus 2. Because it's vertical, it's outside. So this one, this is also a translation. None of the roots stayed the same. 2 things happened here. G of x is equal to f of x. And here we went over 1, 2, 3, 4, 5. So minus 5. We went up 1, so plus 1. Next one. Well, we need to show all the work for this one. I accepted it without all the work shown, simply because this was having some technical difficulties. But just in case you wanted to see where it was coming from. This doesn't need an F in it. It's just that. And that's just equal to 6. So 6 was your answer here. Again, I didn't need to see all the work because technical difficulties. Now, why is f of g of 1 undefined, but g of f of 1 is defined? Well, g of 1 right here is outside the domain of g. 1 can't be plugged into g. So even though if you just plugged it into this and ignored the domain, you'd get an answer, because we've restricted the domain to this, you can't graph it. Now, g of f of 1 does not have the same issue. I can plug 1 into f. It's right here in my domain. That's perfectly fine. If I plug 1 in, I'm going to get 5. 5 falls into the domain of g of x. So that's perfectly fine. I just explained it. I'm not going to write it. Now, find an equation by substituting the expression g of x into the equation for f of x. Well, let's do it. So f of x, I'm going to do f of g, so 6 minus x, and that's going to equal, just replacing every x with the expression for g. It's going to be 0.5 times 6 minus 0.5x. Oh, plus 4.5. Excuse me. I was wondering where the heck that other one came from. So that's going to be 3. That's going to come out to 4.5. A lot of people forgot the negative with the 0.5. Can't forget that. Here's my very original answer. Last but definitely not least, so plot the function. A lot of people did well with that. It's going to end up looking something like this. Now, the next one should have had the same graph on it, and also another graph that ended up looking like that. I accept it if you just had the blue graph here. Now, my terrible drawing notwithstanding, there are going to be reflections over this line, the y equals x line. So that's what I was looking for in 17. How are the graphs of f and f inverse related to the line? There are reflections over them. 18, how do we tell if an inverse of a function is itself not a function? And that can be a horizontal line test on the original, or it can be a vertical line test on the inverse, either one of those. And the last question, anything you put, worked. I just wanted to see what you put, and I hope that you learned something from this, because a test is still another opportunity to learn.